This is part 1 of 2.5. We're going to be proving statements about segments. So in lesson 2.4, we learned about the properties of equality. The addition property, where we add something to both sides of an equation. Subtraction, where we subtract both sides by the same thing. Multiplication, where we multiply both sides by the same thing. Division, where we divide both sides by the same thing. Distributive property, where we can distribute over a set of parentheses. Substitution, when we replaced something in an equation. Reflexive, like the reflection, it's something equal to itself. Symmetric, like symmetry, when you look at the reverse of an object. And transitive, when we're linking things together by what they have in common. So everything listed here is a property of equality, which means that it has to be used with an equal sign. But there are 3 of them in that list that can also be used with a congruence sign. So the reflexive property for any segment AB, we could say that segment AB is congruent to segment AB. Symmetric, if AB is congruent to CD, then I can flip that around and say that CD is congruent to AB. And transitive, if AB is congruent to CD and CD is congruent to EF, link together the 2 CDs to say that AB is congruent to EF. So notice substitution is not listed here. We cannot use substitution with a congruent sign, only these 3. So for example 1, we want to name the property that the statement illustrates. So if EF is congruent to EF, we're looking at our reflection. That's the reflexive property. If FH is congruent to HI and HI is congruent to JK, then FH is congruent to JK. We are linking together by the fact that we had 2 different HIs. So FH is congruent to JK by transitive. And then if AD is equal to DE, then DE is equal to AD. So notice this is back to an equal sign, but it's okay because it could go either way. So this is symmetric property. There's a check in here for you. Pause if you'd like to try it. The answers are posted online. So we have some more definitions that we can use. So we have learned a lot of words so far this year, and all the words that we've learned we can use in a proof by using the definition of that word. So the definition of congruence. Segments are congruent if and only if they have the same measure. So if AB was equal to CD, then I can turn that into segment AB is congruent to segment CD. And the reverse is also true. If segment AB was congruent to segment CD, then AB would be equal to CD. For the definition of a midpoint, the midpoint of a segment divides a segment into 2 congruent parts. So if M is the midpoint of segment AB, right, that would have looked like this. Here's A, here's B, M is the midpoint. We would know that those 2 pieces are the same, so that would be segment AM is congruent to segment MB or BM. Bisects is very much like midpoint. So any line, race, segment, or point bisects a segment by dividing it into 2 congruent parts. So very much like our midpoint thing, if L bisected AB, let's pretend that our picture here also used line L, then we could say the same thing. We could say that segment AM is congruent to segment MB. So in this example, we're going to complete the proof about segments. So every geometric proof that we do, we're going to have some given information and then something that they want us to prove. So notice next to prove it doesn't say given, so we are not going to give a reason as given for the proof statement, but anything that's listed here in this first line, when I see it in the proof, the reason I'm writing it is because it was given to me. So step 1 is given because they told me T is the midpoint of segment SU. And then I notice I have another given down here in step 4, and I haven't used the rest of this yet. So I'm going to put that in here. ST equals 7x, and TU equals 3x plus 20. So now I'm looking for each step. I'm trying to figure out what allowed me to say this step. And oftentimes, what allows me to say this step came immediately before it. Not always, but oftentimes. So here, I'm saying that segment ST is congruent to segment TU because T was the midpoint of segment SU. So the reason I'm able to say those are congruent is by the definition of midpoint. And here's a tip. We're always going to see a word and we're going to use the definition of that word. It might be in the reason we're for that statement, but a lot of times it'll happen in the step after. So now my next line, I have the same letters as I did in step 2. I have ST is equal to TU, when before I had segment ST is congruent to segment TU. So all I've done is change it from congruence to equal. So that would be the definition of congruence. Either way we go, equal to congruent or congruent to equal, definition of congruence. All right, we already knew we had our next given statement there. And now I have 7x equals 3x plus 20. In this equation, ST was equal to TU, but ST is the same thing as 7x, so I can replace ST with 7x. And TU is equal to 3x plus 20, so I can replace TU with 3x plus 20, and that's what I did. So we can call this substitution. Really, it's hard to see, and the reason I'm calling it substitution instead of transitive, which is what it really is because the transitive is much harder to see on this one, but just know that it is in fact technically using transitive. So now that I have this equation, I'm going to go back to solving the same way I know how to solve, right? I'm going to use the subtraction property. I'm going to subtract 3x from both sides. So now I have 4x equals 20. And my last step, if I use the division property, I can divide both sides by 4 and we get x equals 5. And that is what I wanted to prove. The statement that it says to prove will always be the last statement in our proof. So even if you didn't know what else to fill in the statements column, you could always put that in the very last spot so you know you at least get something correct in the proof. So here's one for you to try. Pause if you'd like to give it a shot. Answers are posted online. Our next example. So this is mostly going to just be filling in the reasons. So we are first given that B is the midpoint of segment AC. And now I'm saying that segment AB and segment BC are congruent, and that's because I saw the word midpoint. So we're going to use definition of midpoint. And now I have segment BC is congruent to segment AB. So we're taking the same step we saw here, but we reversed it. So remember, that's called the symmetric property. And now step 4 tells me I have another given. The only given I haven't used yet is that segment AB is congruent to segment CD. So that's what I'm going to fill in there. So now step 5, I have BC is congruent to CD. I have seen a BC. I saw the BC right here. And I have seen a CD. I saw CD right here. And when I look at these two steps, step 3 and step 4, I can link together the AB that they have in common. So remember, when we're linking things, we're using the transitive property. And now my very last step, I knew that BC and CD were congruent, so now I'm saying C is the midpoint of BD. I see the word, I'm going to use the definition of that word. So this is one of the instances where we're using the word in the same line that we see it. So we learned some postulates and theorems in chapter 1 that we could use as well besides the definitions, and one of them is the segment addition postulate. We use this anytime we're stuck in a proof and we need to introduce more segments into it, whether we didn't have the smaller pieces or whether we didn't have the bigger piece. So this is not based on anything that happened previously in a proof. It just comes out of nowhere. And the segment addition postulate says that the two small pieces, AB plus BC, would be equal to the whole segment, which is AC. And it's okay to write it the other way. I could start with the whole segment and then say it's made up of the two small pieces. It doesn't matter which way we do this. So for example 4, let's complete the proof. I'm told that E is the midpoint of DF. That is given. And I'm going to right away, I see prove DF equals 2DE. I'm going to fill that in down here. So if I see the word midpoint, I'm going to use the definition of midpoint. And then what it means to be the midpoint is it splits it in half. So if E was the midpoint of DF, then DE is congruent to EF. In the next step, I've taken these same segments, but now I've said their measures are equal. So that's the definition of congruence. And now I have DE plus EF equals DF. I have not seen anything with addition before. I have not even seen DF before. So something tells me this came out of nowhere. And I'm going to look at my picture. DE is this piece plus EF is this piece equals the whole thing. So that is the segment addition postulate. Anytime we create the equation to show one big segment is made up of smaller segments, that's the segment addition postulate. So now it tells us we're going to use substitution. So if I look at what I already have in my proof, I have an equation where DE plus EF is DF. And I know that DE and EF are the same thing. So I can replace one with the other. So what I'm going to do is I'm going to replace this EF with the DE that it's equivalent to. And I'm choosing to replace EF because I want DE in my answer. If I look down at the very bottom, they have DE, so that's what I want to focus on. So I'm going to do DE plus DE equals DF. Right, that's substitution. Simplify, we have like terms that we can combine. So DE plus DE is really 2DE. And that's simplifying. That was combining like terms. And now I have the same statement here. I have 2 times DE equals DF, and now DF equals 2 times DE. So we've switched the order, right? We've looked at our symmetry. So that is the symmetric property. One more example to do together. So in number 1, I'm given that AB and CD bisect each other at point M. And I see step 3 also says given. So that's going to be segment CM congruent to segment BM. And I know the very last line should be AB equals AM plus DM. So now let's try our proof. I see AB and CD bisect each other. And now I'm saying 2 pieces of a segment are congruent. So if I saw my word, I'm going to use the definition of that word. Definition of bisect. And then we were given that segment CM is congruent to segment BM. And now I have segment BM is congruent to segment DM. So BM I did in fact see here, and DM I did in fact see here, and both of them were congruent to segment CM. So we're linking together using the transitive property. Now I've taken my work from step 4 and turned it into equals instead of congruent. So that's the definition of congruence. And they tell me I want to use the segment addition postulate. So there's 2 different segments I could be using in this picture. I could be using CD or I could be using AB. And if I look at the very last step, I know that I want AB equals something. So that's what I'm going to focus on. I'm going to use AB equals, and let's look at our AB segment here. The 2 pieces that make up AB are AM and BM. So my last step looks very similar to step 6. We still have an AB, we still have equals, we'll still have AM, we still have plus, but now the BM turned into a DM. We replaced the BM with the DM. So that means we used substitution. So this is the last check-in. Pause if you'd like to give it a try, but answers are posted online. And that is the end of 2.5 segment proofs.